Hello students, in this video I am going to teach mathematical induction. You would have heard about induction, deduction. You know what is deduction? You are getting some particular cases from a general truth or from general information. From a general statement you are getting some particular cases, that is called deduction. From particular cases you are getting a general statement. You are deriving a general statement, that is called what? Induction. So here mathematical induction. So here we are proving some statements or some identities, some results through some particular cases. So we call it as mathematical induction. Here mainly we are proving the statements it is true for natural numbers. What are natural numbers? 1, 2, 3, 4, etc. Right? So we are proving the result is true for all natural numbers. For example, you know 1 plus 2 plus 3 plus etc. up to n. What is 1 plus 2 plus 3 plus etc. up to n? You would have studied in 10th standard, right? n into n plus 1 by 2. So this is a statement. Suppose you want to prove this. The statement what you have to prove, you take it as P of n. I said we can prove this general statement through some particular cases. What are the particular cases? 3 steps are there. Okay, so first step, you have to prove the result is true for 1. Prove P of 1 is true. That is, you prove the result is true when n equal to 1. Second one, assume, we are not going to prove. Assume the result is true for a particular number k. Assume P of k is true. So first one you have to prove. Prove the result is true for n equal to 1. Second one, we are not proving, just we are assuming. Assume the result is true for a particular number k. Maybe 17 or 25, something like that. K is some number, okay? And the third step, and that is the most important one, again you have to prove. Prove the result is true for n equal to k plus 1. Prove P of k plus 1 is true. These 3 are called principles of mathematical induction. Already I said what is induction, what is mathematical induction. So these are called principles of mathematical induction. So first step, the statement what you have to prove, you take it as what? P of n. Then there are 3 steps. First you prove the result is true for n equal to 1. So how to prove that? I will explain to you when you do the sum. Okay, just try to understand. First you prove the result is true for 1. Second, assume it is true for k. Then using that you prove it is true for k plus 1. So you may ask, sir, if I do these 3, how can you say it is true for all natural numbers? I am going to explain this. Please listen carefully. Many students, they learn mathematical induction, but they don't know how it is true for all natural numbers. So please listen, that's very important. We want to prove it is true for 1, 2, 3, 4, 5, etc. Right? So first step, what we did, prove P of 1 is true. That is, we proved for 1. Yes. We didn't prove for 2, 3, 4, 5 and all. We proved only for 1. Right? Then another thing, second and third together you take. The second one we are assuming something, and the third we are proving something using that. Assume it is true for k, using that we are proving it is true for k plus 1. So what is the relation between k and k plus 1? Immediate next number, right? Consecutive number, k and k plus 1. So first one is not, we don't know whether it is true or not, it is an assumption. Assume P of k is true, then if it is true, definitely you can prove this. Third statement, okay, P of k plus 1 is true. So if you combine these two, what you have to understand from that, you know, if it is true for k, it will be true for k plus 1. If it is true for k, it is true for k plus 1. So we assume it is true for k, using that we proved it is true for k plus 1. So if it is true for k, it is true for k plus 1. K and k plus 1, how they are related? The next term. So k is one term, k plus 1 is the next term. If it is true for k, it is true for k plus 1. Meaning, if it is true for some number, it will be true for the next number. If it is true for a particular number, it will be true for the next number. That is what you have to understand from second and third. If it is true for 20, it will be true for 21. Already we proved it is true for 1. So it will be true for the next number. What's the next number? 2. It is true for 2. If it is true for 2, it will be true for the next number. What's the next number? 3. If it is true for 3, it will be true for 4, and so on. So you can say it is true for all natural numbers. Hope you understood this. First, you prove it is true for 1. Then, assume it is true for k, and you prove it is true for k plus 1. So what do you have to understand from here? If it is true for a number, it will be true for its next number. Already proved it is true for 1, so it will be true for 2. Since it is true for 2, it will be true for 3, and so on. So then you can say it is true for all natural numbers, right? Hope you understood this. That's all the theory part. Now, actually there are 2 types of questions. One question series, questions like this, 1 plus 2 plus etc. And some series they give, okay? And another type, prove it is divisible by. In this video, I'm going to take the first part. Now let's move on to the first question. Look at this question. Using mathematical induction, prove that 1 plus 2 plus etc. up to n equal to n into n plus 1 by 2. It's one of the basic questions. So please listen here. So for every question, the method remains same. So listen very carefully. So totally there are 3 parts. Only the third part you have some work. Okay. So you take the statement to prove. You take it as what? P of n. So here P of n is, so it is in n, right? It's an equation in n. So you take P of n. Suppose m, you write P of m. If it is k, you take P of k. So the entire statement 1 plus 2 plus 3 plus etc. up to n equal to n into n plus 1 by 2. This is what we have to prove. For that, there are 3 steps. The first one, we have to prove P of 1 is true. We have to prove P of 1 is true. Please listen what's the method you have to follow here, Left side, you take the first number. Left side, you take the first number. Right side, wherever n comes, you put n. Wherever n comes, you put n. Replace n by 1, right? So left side, you take the first number. Here, the first number is 1. Right side, you replace n by 1. Wherever n comes, you put 1. So 1 into 1 plus 1, it is 2 by 2. 2 to cancel. You are getting 1 equal to 1, which is true. So the first part is over. Some writing work is there. Therefore, P of 1 is true. First part is over. P of 1 is true. So principles of mathematical induction, there are 3 parts, right? Now the second part, second step, assume P of k is true. Assume P of k is true. Nothing to prove here. Assume P of k is true. P of n, this is P of n. P of k means wherever n comes, you put k and you take it is true. Assume P of k is true. The meaning, instead of n, you put k. Just to copy the full statement. 1 plus 2 plus 3 plus etc. up to k equal to k into k plus 1 by 2 is true. It's only our assumption. And take this as 1. So first step, you prove P of 1 is true. Second step, assume P of k is true. And the third step, and that is the most important one, you have to prove P of k plus 1 is true. You have to prove P of k plus 1 is true. For that, what do you do now? This is the one thing you have some calculations, so listen very carefully. Left side, here you have k terms, you take the next term also. So you write these terms first. 1 plus 2 plus 3 plus etc. up to k plus the next term. How can you find the next term? See the sequence, 1, then 2, then 3. How you are getting the next term? By adding 1. Suppose adding 3 means here the last term you add 3. Here 1, 2, 3, 4. So we are adding 1. So k, the next term is k plus 1. And you have to prove it. So don't simply write the answer. What answer you are supposed to get? I'll give a hint for that. Okay. So what answer you are supposed to get, Wherever n comes in the answer, this is the answer you had, right? Wherever n comes, you have to get k plus 1. Wherever n comes, you have to get k plus 1. Because we are finding P of k plus 1, we are going to prove it. So what answer you are supposed to get? Wherever n comes, you should get k plus 1. So instead of n, you should get k plus 1. Then the second term, second factor, k plus 1, it is k plus 2 by 2. This is the answer you are supposed to get. Once you get this answer, you say P of k plus 1 is true. So what answer you are supposed to get? K plus 1 into k plus 2 by 2. So you are supposed to get k plus 1 into k plus 2 by 2. So once you get this answer, you can say P of k plus 1 is true. This is the method, okay, you have to follow. Otherwise what happens, even after getting the answer, you don't know whether you got the answer or not. Okay, so this is the answer you are supposed to get. Once you get this one, you can say, therefore P of k plus 1 is true. We have to prove this result, okay, I'll tell you how to do that. P of k plus 1 is true, then you can say the final conclusion, therefore, by the principle of mathematical induction. Mathematical induction, P of n, the statement, right? P of n is true for all natural numbers, or you can say n belongs to n, for all n belongs. These conclusions you must write, okay? So now only thing you have to get this answer. Please listen how to prove that one. I'll explain. Please listen. So this is equal to, from here to here, up to k. So we assumed some answer, right? In the second step, equation number 1, 1 plus 2 plus etc. up to k, we assumed its answer as k into k plus 1 by 2, k into k plus 1 by 2, plus one extra term. What's the next extra term? K plus 1. Using the result number 1. Because that you can use it. Because we assumed it is true. Using that only we are going to prove P of k plus 1, right? So now what do you do? See the answer also. So otherwise what happens when you multiply, take LCM and all? See, in the answer we need k plus 1. K plus 1 is there in both the terms, right? So take k plus 1 outside. What's the remaining? K by 2 plus 1, right? So you are getting k plus 1 into, you take LCM. What's LCM here? 2. You will get k plus 2. Just you multiply. See, are you got the answer now? Yes. K plus 1 into k plus 2 by 2. Yes, you got it. That's all. You can say P of k plus 1 is true. Then by the principle of mathematical induction, it is true for all natural numbers. I'll explain once again. When you do another 1 or 2 sums, you'll find it very easy. Okay, please listen. This is one type. A series is given. One statement given. To prove, we take the statement as P of n. First, P of 1. Left side, you take the first number. Right side, replace n by 1. Wherever n comes, you put 1. Check the answers are same. Here we are getting 1 equal to 1, or 5 equal to 5, 7 equal to 7, whatever it is. Both LHS and RHS, you should get the same answer. Then you can say P of 1 is true. Second step, assume P of k is true. Very simple. Just copy the statement. Only thing, instead of n, you put k and you say it is true. Equation number 1. Then P of k plus 1. Copy that k terms plus the next term. See the next term, how you are getting. In this particular question, adding 1, right? So just k, the next term is k plus 1. That you'd simplify. Before that, you see what answer you are supposed to get. How we got that one? In the question, wherever n comes, you have to get k plus 1. So you got some answer and we proved that one. Okay, then conclusions you are right. P of k plus 1 is true. Therefore, by the principle of mathematical induction, the given statement, that is P of n, is true for all natural numbers. Shall we go for the next question? Look at this question. By the principle of mathematical induction, prove that 1 plus 3 plus 5 plus etc. up to 2n minus 1, the answer is what? N squared. First, we give a name to the statement to prove P of n is equal to 1 plus 3 plus 5 plus etc. up to 2n minus 1. Now, there are 3 steps. The first one is P of 1. Left side, I said take the first number. Here, unfortunately, here also the first number is what? 1. Okay, so 1 equal to P of 1. So 1, nothing like that. You take the first number. Suppose the first number is 4, you write 4. Right side, wherever n comes, so that I didn't write fully, right? Equal to n square. Wherever n comes, you put 1. So for n you give 1, you will get 1 square. So 1 equal to 1 square is also 1. 1 equal to 1, which is true. So you can say, therefore, writing work is there. So you have to do every step, right? So P of 1 is true. What is the second step? Assume P of k is true. Assume P of k is true. So what do you do? Just to copy the statement, right? Only thing, instead of n, you put k. assume P of k is true. So 1 plus 3 plus 5 plus etc. plus 2k minus 1 equal to k square is true. Like that we are assuming, right? Take it as 1. So 2 steps over. First step, second step, anyone can do that. Now let's see the third step. Third step is P of k plus 1. So that one I said how to do that. P of k plus 1 means you copy these k terms first. So that is 1 plus 3 plus 5 plus etc. up to 2k minus 1 plus add one extra term, right? You add the next term. How we are getting the next term here? See very careful. Don't simply add 1. The previous question is 1 because 1 plus 2 plus 3 adding 1. But here 1 plus 3 plus 5. How we are getting the next number? By adding 2, right? So 2k minus 1 we have. 2k minus 1 we have. To get the next number, you have to add 2. If you add 2, you will get 2k plus 1. This is the number you are supposed to add. You have to be very careful in this, right? What answer you are supposed to get? Instead of n, you put k plus 1. So n square. So k plus 1 square. Instead of n, it is k plus 1. So you are supposed to get k plus 1 the whole square. K plus 1 the whole square. Once you get this answer, it's over. Only writing work, right? Now listen how to get this one. So here, up to this, every sum same method only. Up to this, we assumed the answer is what? K square. Plus that extra term, what is that? 2k plus 1. So that is k square plus 2k plus 1. You got the answer? Yes, if you factorize, you will get it. K plus 1 square, expand and see a plus b the whole square, a square, plus 2ab, 2 into k into 1, 2k, plus b square, 1 square is 1. Yes, you got it. So what can you say? Which implies p of k plus 1 is true. So finally you say, therefore, like previous question I wrote, no? By the principle of mathematical induction, P of 1 is true for all natural numbers, and you must write the conclusion. Okay, so hope you understood this. Now let's move on to the next question. 1 cube plus 2 cube plus 3 cube plus etc. up to n cube. This is actually sigma n the whole square, right? N into n plus 1 by 2 the whole square. So if you put square for every term, actually this is what the formula, n into n plus 1 by 2 the whole square. So if you square every term, n square, n plus 1 square by 2 square. What is 2 square? 4, right? You are get this is the, okay, actually this is the third formula, right? Now let us see how to do this. You take the statement as P of n. Let P of n is 1 cube plus 2 cube plus 3 cube plus etc. up to n cube equal to n square, n plus 1 square by 4. 3 steps. The first step is P of 1. We have to prove P of 1 is true. Left side, you take the first number. What is the first number? 1 cube. Right side, wherever n comes, you put 1. So 1 square, it is 1. 1 plus 1, 2. 2 square, 4 by 4. 1 cube is 1. 4, 4 cancel, you are getting 1. 1 equal to 1, which is true, right? Therefore, you can say P of 1 is true. So first step over, right? So what's the second step? Assume P of k is true, right? Second step, assume P of k is true. So what do you do? Just copy the question, right? Only thing, instead of n, you put k. So that is 1 cube plus 2 cube plus 3 cube plus etc. up to k cube equal to k square into k plus 1 square by 4 is true. It is our assumption. Take it as 1. Now the last step and the most important one. So using this, we have to prove P of k plus 1 is true. By this time you got good idea, right? Left side, you copy this fully. 1 cube plus 2 cube plus 3 cube plus etc. up to k cube plus the immediate next term. How we are getting next term? Cube is there, okay? Then 1, 2, 3 adding 1. So k cube, it is k plus 1 cube. What answer you are supposed to get? That's very important, right? Wherever n comes, k plus 1. So k square, it becomes k plus 1 square. Next, instead of k, it is k plus 1. K plus 1 plus 1. So same thing here, right? Instead of n, you put k plus 1. K plus 1 plus 1. So k plus 2 the whole square. K plus 2 the whole square by 4. This is the answer you are supposed to get. Once you get this answer, you can say P of k plus 1 is true. And by the principle of mathematical induction, it is true for all natural numbers. Now please listen how to get this answer. Listen. So this is equal to, up to this, we assume the answer as what? K square into k plus 1 square by 4. Plus one extra term, what is that? K plus 1 cube. Now see the answer also. This is the answer you have to get. Such a way we proceed. What is common in both? K plus 1 square. Here k plus 1 square, here k plus 1 cube. You can take k plus 1 square outside, right? So I am taking k plus 1 square outside. So what's the remaining? K square by 4 plus one more k plus 1, right? K plus 1. Now we take LCM. K plus 1 square. Take 4 as LCM. So what you are getting? K square. By this 4 you multiply. 4 into k. 4k plus 4 into 1 is 4. You got the answer now. By 4 is there. Yes, you got it. K plus 1 square. Yes. So are they same, these two? Either you factorize that or you expand and see. A plus b the whole square. That is easy, right? A plus b the whole square is a square. K square. 2ab. 2 into k into 2. 2 2s are 4. 4k. Yes. Plus b square. 2 square is 4. Yes, you got it. So no need to factorize and show. Okay, this is the answer you are getting. So P of k plus 1 is true. So by the principle of mathematical induction that you have to copy. Okay, by the principle of mathematical induction, P of n is true for all natural numbers. Let's move on to the next question. Look at this question. Can you read this question? Some of you may read it as 1.2, 2.3. No, it is 1 into 2. 1 into 2, 2 into 3, 3 into 4, etc. n into n plus 1. And the answer is n into n plus 1 into n plus 2 by 3. So we take the statement as P of n. I'm not going to write all the steps, you know that. So first P of 1. P of 1 means wherever. No, left side you take the first term. What is the first term here? 1 into 2. Right side, wherever n comes, you put 1. So 1 into 1 plus 1, it is 2. 1 plus 2, it is 3. Whole divided by 3. Left side 1 into 2, it is 2. Right side 3 get cancelled. 1 into 2, it is true. It is 2, right? 2 equal to 2, which is true. So you can say P of 1 is true. Second step, assume P of k is true, right? So assume P of k is true. What's the meaning of that? 1 into 2, right? 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. up to k into k plus 1. N into n plus 1. Instead of that, you put k into k plus 1. Right side, k plus 1, k plus 2 by 3. K plus 1, k plus 2 by 3 is true. It is our assumption. Take it as 1. Now using this only, we are going to prove the third step, that is P of k plus 1. So listen very carefully. So left side, as I said earlier, you copy the same thing first. What you written here. So 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. up to k into k plus 1. Plus we want one more extra term. Can you say what is the next term? See, 1, 2, 3, etc. up to k. The next term start with k plus 1. Don't stop, into one more. If I write 1, into 2. If I write 2, into 3. That is immediate next number. 3, 4. K plus 1. K plus 1, k plus 2, right? The next number is k plus 2. So this is what you have to add here. And what answer you are supposed to get, wherever n comes or wherever k comes, you have to get k plus 1. So this becomes k plus 1, k plus 1 plus 1, k plus 2, k plus 1 plus 2, k plus 3. So k plus 1, k plus 2, k plus 3 by 3. So k plus 1, k plus 2, k plus 3 by 3. This is what you are supposed to get, right? Once you get this, you can say P of k plus 1 is true. And by the principle of mathematical induction, it is true for all natural numbers. Now let us see how to get this. This is the most important thing. Okay. So here, up to k terms, up to this, we assume the answer as this one, equation number 1. K into k plus 1 into k plus 2 by 3. Plus one extra term. What is the extra term? K plus 1 into k plus 2. And you can write here using the result number 1. Okay, now you see the answer also. So based on that you have to proceed, right? See, what is common in both? K plus 1, k plus 2. Common, right? In the answer also we want k plus 1, k plus 2. So take it outside. Otherwise, if you don't know the answer, what happens? You don't know what to do, right? We multiply everything, take LCM, then arriving at the answer, and we don't know whether you got the answer or not. So you tease, what is common here? K plus 1 into k plus 2 common. What's the remaining? K by 3 plus in the second one nothing left out, so 1. So k plus 1 into k plus 2. You take LCM here, 3 is LCM, you are getting k plus 3. Got the answer? Yes, k plus 1, k plus 2, k plus 3 by 3, that's all. So P of k plus 1 is true. By the principle of mathematical induction, it is true. P of n is true for all natural numbers. Let's move on to the next question. Listen. So you take the statement as P of n. So, okay, so that I am not going to waste time. You know what are the steps you have to write. Then first step, P of 1. Left side you take the first number. I said don't put 1 every time. Now the first time is what? 4. So 4 equal to right side wherever n comes you put 1. So 2 into 1. 2 into 1 plus 1 is 2. So 4 equal to 4. Yes, which is true. So you can say P of 1 is true. First step over, right? What's the second step? Assume P of k is true. What do you do? Wherever n comes you put k. So 4 plus 8 plus 12 plus etc. up to 4k equal to 2k into k plus 1. Just we replace n by k is true. Take it as equation number 1. And the next one is a very important step. P of k plus 1, right? So the third step is P of k plus 1. So copy these k terms plus one more term, right? So 4 plus 8 plus 12 plus etc. up to 4k plus the next term. How you are getting the next term? 4, then 8, then 12, keep on adding 4. So after 4k, what's the next term? You add 4 more, right? So 4k plus 4. And what answer you are supposed to get? So 2 into, instead of k, you have to get k plus 1. Next one is k plus 1, right? Instead of k, you have to get k plus 1. K plus 1 plus 1. It is k plus 2. This is the answer you are supposed to get. Now let us see whether you are getting this or not. Up to this, we have assumed the answer as 2k into k plus 1. One extra term, what is that? 4k plus 4. So that is 2k into k plus 1 plus what is common here? 4 is common. What's the remaining? K plus 1. Now in these two terms, what is common? You can take 2 and 4, no? You can take 2 outside. And this k plus 1 is also common in both. So 2 into k plus 1. What is left out? First one, nothing, only this k is there. Plus in the second one, we have taken 2 outside, but 4 is there, no? 2 into 2, so plus 2. Got the answer? Yes. So P of k plus 1 is true. You can say, therefore, by the principle of mathematical induction, by the principle of mathematical induction, P of n is true for all natural numbers. N belongs to capital N. Okay, let's move on to another question. 1 plus 4 plus 7 plus etc. Some statement. Okay, it's a sequence. You take series given, take it as P of n. Let P of n stands for 1 plus 4 plus 7 plus etc. up to 3n minus 2 equal to n into 3n minus 1 by 2, right? The first step, P of 1. Left side you take the first number. Right side wherever n comes you put 1. 3 into 1, 3 minus 1, 2 by 2. Cancel. So you are getting 1 equal to 1. You write the steps which is true. So P of 1 is true. Second step, assume P of k is true. What do you do? Wherever n comes you put k. So you are getting 1 plus 4 plus 7 plus etc. up to 3k minus 2 equal to k into 3k minus 1 by 2 is true. Because it is only an assumption. Now please listen the last step, third step, P of k plus 1. Copy these k terms first, 1 plus 4 plus 7 plus etc. up to 3k minus 2 plus next term. How we are getting next term? 1, 4, then 7, keep on adding 3. So what we have here, 3k minus 2, you have to add 3. If you add 3 more, 3k plus 1, right? 3k plus 1. And very important thing, what answer you are supposed to get. If you write some wrong answer and you will check, you won't get it right. So be very careful. So instead of k, you have to get k plus 1, right? So the first term became k plus 1. By 2 also, okay, no problem. But the main thing is that 3k minus 1. 3k minus 1. For k, you have to get k plus 1. 3 into k plus 1 minus 1. Multiply by 3, 3 into k, 3k plus 3 into 1, 3 minus 1. So when you simplify, 3k plus 2, this is the answer you are supposed to get. 3k plus 2. Okay, so let us see how to get this answer. Up to this, it is k into 3k minus 1 by 2 plus 3k plus 1, right? So nothing is common here. So just you take LCM, right? So when you take LCM, 2 is LCM. Here just you multiply by k. So 3k square minus k plus the 2 goes there. By the 2 you multiply both. 2 into 3k, 6k plus 2. Simplify. 3k square plus 5k plus 2 by 2. Got the answer? Yes, I'm going to leave it. No space to write, no? It is correct only. If you factorize, you will get this. Or you multiply and check, you will get that one. Okay, multiply and check, that is easy, no? So k into 3k, it is 3k square. K into 2, 2k. 1 into 3k, 3k. 2k plus 3k, it is 5k. Yes. 1 into 2, it is 2. Nobody is going to ask how, whether, where is the factorization? No, that's lower class. You are all very intelligent students, so we know, yes, you would have done properly. But you check it while multiplying, you are getting the answer or not, okay? So, hope you understood. So, you can say, so P of k plus 1 is true. Then the conclusion you write, by the principle of mathematical induction, it is true for all natural numbers. Just I am going to help you one more question. This also already you studied in 10th standard. 1 square, 2 square, 3 square, etc. up to n square is n into n plus 1 into 2n plus 1 by 6. You take the statement as P of n. The first step, P of 1. Left side you take the first term. What is the first term? 1 square. Right side wherever n comes you put 1. So 1 into 1 plus 1, 2. 2 into 1, 2 plus 1, 3 by 6. 2 3s are 6, cancel. So 1 square is 1 equal to 1, which is true. So P of 1 is true. That steps you write. Second step, assume P of k is true. That also you copy that. Okay. So what you get? 1 square plus 2 square plus 3 square, etc. up to k square equal to k into k plus 1 into 2k plus 1 by 6 is true. It is our assumption. Now the last step, P of k plus 1. Listen very carefully. So then let them give any question, you can do that. Okay. So the third step, P of k plus 1. You copy these k terms first. So these k terms you write to 1 square plus 2 square plus 3 square plus etc. up to k square plus immediate next term. Everything square is there. 1, 2, 3, 4 continuous numbers. So add 1. K plus 1 the whole square. What answer you are supposed to get? For k, you have to get k plus 1. So first term is k plus 1. Second term, k plus 1 plus 1. So k plus 2. The third term we'll do the calculation by 6. The third term is 2k plus 1. So we write separately and see. 2k plus 1. Instead of k, you have to get k plus 1. 2 into k plus 1 plus 1. Multiply 2k plus 2 into 1, 2 plus 1. That is 2k plus 3. You are supposed to get this. 2k plus 3. Now let us see whether you're getting that answer. Like previous question, we can do this. Please listen up to this. You know the answer. What is the answer for that? Using the result number 1. K into k plus 1 into 2k plus 1 by 6. Plus one extra term. What is that? K plus 1 the whole square. What is common in both? K plus 1. Take it outside. In the answer also we need that. K plus 1 is taken out. What's the remaining? K into 2k plus 1 by 6 plus what? K plus 1. You take LCM now. So this is equal to k plus 1 into. The LCM is 6, right? So multiply by this k, 2k square plus k plus 6 into. So multiply both the terms by 6. So 6k plus what? 6 into 1 is 6, okay? That is k plus 1 into, simplify this, 2k square plus 1k plus 6k, it is 7k plus 6 by 6, are you right? The whole divided by what? 6, right? 7k plus 6 whole divided by 6. Got the answer or not? K plus 1, yes. 6, yes. These two you multiply and check. Will you get this one? K into 2k, 2k square. K into 3, 3k. 2 into 2k is 4k. 3k plus 4k, 7k. Then 2 into 3, 6, yes. If you factorize, you will get it. So you can say P of k plus 1 is true, right? And conclusion, don't forget, right? By the principle of mathematical induction, it is true for all natural numbers. So that's all. Hope you understood all these things. In the next video, I'll teach you the next type questions. We'll continue in the next video.